SK015.
Alright, Assalamualaikum warahmatullahi wabarakatuh and Salam Sejahtera. So welcome back to this channel, guys. Okay, so in today's video we are going to do the post lab for experiment 2, acid-base titration, determination of the molar concentration of hydrochloric acid solution. Okay, so for the first part of this video, okay, we are going to have a look at the results obtained from this experiment. Okay, and this experiment actually consists of 3 parts, part A, part B and part C, and we are going to have a look at the first part. Okay, part A, preparation of the standard solution of oxalic acid. Remember the one that you have prepared in the 250 ml volumetric flask. Okay, so in this first part or part A, firstly what you did were you have weighed the mass of hydrated oxalic acid. Okay, and stated in the manual, you guys should weigh how many grams? Yes, 3 grams. And let's say this was the mass of the hydrated oxalic acid weight, right, 3 grams. 3. Please make sure when you record the reading for the masses, it must be in 4 decimal points. So in this case 3.0000. So for those who get 2.9999, yes, record it as 2.9999 or 3.0001. Okay, because the mass should be nearest to 0.0001 grams. Okay, and then second, right, so the molar mass of hydrated oxalic acid. So actually you can calculate this, okay, using from the molecular formula of the hydrated oxalic acid. So we can calculate this molar mass of hydrated oxalic acid, which is 126.07 grams per mole. Alright, okay, next we are going to determine the moles of hydrated oxalic acid. In this case, we want to know in this 3 grams, 3.0000 grams of hydrated oxalic acid, actually how many moles of hydrated oxalic acid in that 3 grams of hydrated oxalic acid. So how to calculate these moles? Yes, mass of hydrated oxalic acid divide by molar mass of hydrated oxalic acid. So in this case 3 grams divide by 126.07 grams per mole, and we are going to get, yes, 0.0238 moles. Okay, so this is the mole of hydrated oxalic acid. Right, next, the volume of oxalic acid solution prepared. Okay, how many milliliters, guys? We were using how many ml of volumetric flask? Yes, 250 milliliters. So that's why the volume of oxalic acid solution prepared in this experiment is, okay, 0.250 liters or 250 milliliters. Okay, next, and finally we are going to determine the molarity or the concentration of oxalic acid solution that we have prepared. Okay, so molarity equals to mole of solute. So in this case, mole of hydrated oxalic acid divided by volume of oxalic acid solution prepared in liters. So if we substituted this, we are going to get 0.0238 moles divided by 0.250 liters, and the concentration or the molarity of the oxalic acid solution is, okay, we are going to get 0.0952 mole per liter or molar. But remember, this concentration is for 3 grams of hydrated oxalic acid. So for those who get 2.9999 or 3.0001, so your molarity would be slightly different from this molarity. Alright, we have come to the second part, or part B of this experiment, standardization of 0.2 molar sodium hydroxide solution. Okay, so this is the table where you need to record your data. So in this video, I'm going to show to you the examples of the readings obtained from this experiment. But you guys need to use your own readings, right? Okay. So in this part B, we need to do the titration. Okay. Firstly, we are going to start with the gross titration. So let's say in this case, I started with 0.00 milliliters of sodium hydroxide. Okay, remember, whenever we are going to record the reading of the burette, it must be in 2 decimal points. Even though you started with at 0, you must record it as 0.00 milliliters. Okay, and then we start the titration. Okay, we start the titration, and we are going to stop when we are going to stop your titration. Yes, once the color of the solution changes from colorless to pale pink. Okay, pale pink, and then we are going to stop the titration. And this is the point that we call the end point. End point, the point at which the color of the indicator changes. Okay, so in this case, since we were using phenolphthalein, okay, so the color changes would be from colorless to pale pink. Okay, so let's say for this part B, what we get was the endpoint occurred once the volume of the added sodium hydroxide reached 23.8, and then we stop. Right, so this will be the gross reading. Okay, the gross reading, okay, 23.8 milliliters. Right, and then we are going to continue with another 3 readings, first, second, and third. Okay guys, since the volume of the burette, okay, is 50 ml, the maximum is 50 milliliters. Okay, so do you think, is it enough, okay, for us to continue with the titration, or we should add more sodium hydroxide? Yes, okay, it is enough. Why? Because here, from the gross reading here, the volume of sodium hydroxide used was just 23.8, and the total volume, since we started from 0, so we are going to have enough remaining sodium hydroxide to be used in this first reading. So in this case, no need for us to add more sodium hydroxide. But let's say if you are if your sodium hydroxide is not enough, okay, maybe some of you get 25 or 26 ml. So I don't think it is enough for you to continue with the first for the first titration. Okay, so you need to add more sodium hydroxide. Okay, and that's why what I'm going to highlight here, actually it is not necessary to start from 0, guys. Not necessary to start from 0. Okay, so for the first reading, so this will be the initial reading, okay, for the first titration. Okay, first titration. Just now what we did was the gross titration. Okay, and then we're going to start with 23.8, and then we do the titration until the end point. So let's say in this case, the end point or the color changes from colorless to pale pink occurred at 47.55 ml of the reading of the burette. So if we calculated this, we are going to get 23.75 ml, okay, of sodium hydroxide added. Okay, so right now the reading of the burette, okay, is 47.55. So means that we have enough or not enough sodium hydroxide to be used for the second and third titration. Yes, of course it is not enough. In this case, yes, we need to add more. Okay, we need to add more sodium hydroxide into the burette. Okay, you need to refill your burette. Okay, and as I told you just now, and it is not necessary to always start from 0. You can start from 1 mil, or you can start from 2 mil. Okay, any suitable readings of the burette. Okay, so in this case, okay, I have refilled the burette up until 2 milliliters. So this will be the initial reading for this second titration. Okay, and then the titration begins and it stops at 25.8, which is the end point in this case. Okay, 25.8, and then once we calculated this, okay, 23.8 mil of sodium hydroxide added. Right, and then from 25.8, okay, continue with the titration, and it stops at 49.55 mil, and the volume is 23.75. Okay, so if you look at these readings, the volume of sodium hydroxide added, okay, if you notice the difference from gross first, second and third with just 0.05 mil. So in this case, we can say that the readings are consistent. Okay, so remember how to determine whether the reading of our titration, volume from the titration, consistent or not. We are going to base on the difference between the values. So let's say the difference is just 0.05 or less than 0.05, so we can say that the readings are consistent. Okay, and then what you need to do, okay, we need to determine the average volume of sodium hydroxide used in this titration. So this is simple. So what we did, okay, we just find the average of these three. So 23.75 mil plus 23.8 mil plus 23.75 mil and divide by 3, and we are going to get the volume, or the average volume of sodium hydroxide solution used in the titration. Okay, next. Right, so next we are going to balance the equation. Okay, balance the equation. So what we have, so we have oxalic acid. Okay, oxalic acid solution. Remember, this is the one that you have prepared earlier in part A. Okay, so we are just using 25 ml of this oxalic acid. Okay, you pipette, you have pipetted 25 ml or 0.025 liters of this oxalic acid, and then this oxalic acid, okay, reacted with sodium hydroxide, and what we are going to get, okay, so these are the products. Okay, you are going to get sodium oxalate and water. Okay guys, so this equation is not balanced. So how to balance this equation? Okay, so if you look at sodium oxalate here, there are 2 moles of sodium, so we need to multiply the sodium hydroxide by 2. Okay, so when this so there are 2 moles of sodium here, 2 moles of sodium here. However, if you look at the hydrogen, okay, the hydrogen atoms, so here got 2 moles of hydrogen atom, but over here we have H2 and then 2H. So on the left side here, okay, we have 4 moles of hydrogen atom, so that's why at the water molecule here also we need to multiply by 2. Okay, so this is the balance equation. Okay, this is the balance equation. Right. Okay, so this is what we call as equivalence point. So equivalence point means the reaction has completely reacted, according to the equation or according to the stoichiometrical relationship between the reactants in the reaction. Okay, that is what we call as equivalence point. Okay, what is the difference between equivalence point and endpoint? So endpoint is the point at which the indicator changes its colors. Okay, for example, in this experiment, since we are using phenolphthalein, so once the reaction has reached the endpoint, okay, so the color changes would be from colorless, okay, to pale pink. So it means that once the reaction has completed, okay, so the color of the solution in the conical flask would be pale pink. Remember, pale pink, not dark pink. Okay, pale. Okay, try to get as pale pink as you can get. That is the best. Okay, so for those who have already managed to get this pale pink, okay, good job guys. Okay, good job. Okay, right. So this is the end point. Okay. Alright, so next what we are going to do, we are going to calculate the moles of oxalic acid used in this titration. Okay, so firstly, in part A, since we have already determined the molarity of the standard solution of oxalic acid, okay, so in this case 0.0952 moles per liter, right? And then, so how many mils of this oxalic acid that we have used in this titration? Remember, you have pipette. Yes, you have pipetted 25 ml of this solution into the conical flask. So that's why the volume of oxalic acid solution used in this titration was just 0.025 liters. Okay, and now, so let's calculate how many moles of oxalic acid used in this titration. So we are going to use the formula molarity times volume, MV. Remember, MV, molarity times volume. Okay, so 0.0952 mole per liter times 0.025 liters, and we are going to get 0.00238 moles. Okay, so this is the moles of oxalic acid used in this titration. Okay, and then from the balance equation, okay, we know that 1 mole of oxalic acid reacts with 2 moles of sodium hydroxide. But since we are using 0.00238 moles of oxalic acid, so therefore this oxalic acid, 0.0238 moles of oxalic acid, react with 0.00476 mole of sodium hydroxide. So this is the mole of sodium hydroxide reacted with 0.00238 moles of oxalic acid. And then we are going to determine the molarity of this sodium hydroxide solution used, right? Okay, so how to calculate the molarity of sodium hydroxide solution used in this titration? Okay, so remember, mole of sodium hydroxide reacted divided by the average volume of sodium hydroxide solution used, okay, in liters. So it says the mole of sodium hydroxide we have just calculated, okay, just now 0.00476 mole divided by the average volume. Remember the average volume just now 0.02377 liters, and we are going to get 0.2003 mole per liters. Okay, but remember this is based on the readings that I have obtained from this experiment. So you guys need to use your own data. So maybe your answer or your molarity of the solution of this sodium hydroxide solution might slightly differ from what I got here. But don't worry, since we knew that the solution of this sodium solution prepared was 0.2 molar, so that's why your molarity that you should get, okay, it must be close to 0.2 molar or 0.2 mole per liter. Okay, so maybe some of you might get 0.19 or 0.20 something. Okay, it's okay. Okay, don't worry about that. Okay, so it means that we have already standardized this sodium hydroxide solution. Okay, good job. Right. Alright, so we have come to the last part of this experiment, part C. Okay, in this part C, we are going to determine the molarity or the molar concentration of hydrochloric acid solution. And remember, in this part C, what we did actually was the same as part B. The changes was just we are using a different acid. Okay, so in the burette, still sodium hydroxide, the same sodium hydroxide solution, but for part C, we just change the solution in the conical flask. So in this case, we were using hydrochloric acid solution. In part B, we were using oxalic acid, but in part C, we were using a different acid, and this acid was hydrochloric acid solution, and everything else was the same. Okay, the procedures, okay, the titration, okay, still the same. Okay, even the table, the table that we are using for this part C also the same table. Okay, right, so still we have 4 columns here. We have gross, first, second and third. So let's say for the gross reading, so the initial is 0.00, okay, and the final reading is 24, and this is the volume of sodium hydroxide added. And then these are, okay, the data for first titration, and then this is for the second titration, and this is for the third titration. Okay, and if you look at the readings here, okay, for the volume of sodium hydroxide added, still if you look at the first, second and third reading, so the difference okay, of these 3 values or these 3 volume of sodium hydroxide added, okay, 0.05. Okay, and then we need to find the average volume of the sodium hydroxide solution used in this titration in part C. Okay, so same as in part B, so we are going to calculate the average by adding up the 3 volumes of sodium hydroxide solution used from first, second and third readings. Okay, so 24.05 plus 24 plus 24 milliliters and divide by 3, and this is the average volume of the sodium hydroxide solution used in this part C, or titration in part C. Okay, and then we are going to write the equation for this reaction. Okay, so in this reaction we are using hydrochloric acid instead of oxalic acid. So hydrochloric acid solution reacts with sodium hydroxide solution, and we are going to get sodium chloride and water. Okay, so is this equation balanced or not? Yes, so it is balanced, so no need for us to do anything, because it is already balanced. Okay, and then we are going to calculate the moles of sodium hydroxide used in this titration. Okay, so the molarity of sodium hydroxide solution used in this titration is 0.2003 moles per liter. Remember where actually we get this value? Yes, okay, so this molarity actually was determined from part B just now, from part B. So you are going to use the value that you have obtained from part B. Okay, so this is the molarity of sodium hydroxide solution, and then this is the average volume of sodium hydroxide solution used in this titration, 34.02 mil, and then we convert it to liters. We are going to get 0.02402 liters of sodium hydroxide solution, and then we are going to calculate the moles. Okay, molarity times volume, see, mv. Okay, 0.2003 molar times 0.02402 liters, and we are going to get 0.004811 mole. Right, so from the balance equation, okay, so we knew that 1 mole of hydrochloric acid reacts with 1 mole of sodium hydroxide. So therefore, if we have 0.004811 moles of hydrochloric acid, so it should react with 0.004811 moles of sodium hydroxide. Alright. And finally, we are going to calculate the molarity of the hydrochloric acid solution used in this titration. Okay, so mole of hydrochloric acid reacted divided by volume of hydrochloric acid used in liters. Okay, 0.004811 mole divided by 0.025 liters, and we are going to get 0.1924 mole per liter, or 0.1924 molar. So this is the molarity of the hydrochloric acid solution used in this titration, and we have successfully determined the concentration of this hydrochloric acid. Alright, good job, guys. Okay, and then these are some exercises that I want all of you to do, or to answer this in your lab report, for this experiment. So the first question is it necessary to know the exact concentration of oxalic acid in order to determine the concentration of sodium hydroxide solution? So is it necessary? I want you to explain this in your report. That is the first question. The second question is, does the addition of water in step 7, so for those who are wondering what is step 7, so if you look in the manual, so this is your step 7, see there, or step 7, so rinse the unreacted solutions at the inner wall of the conical flask with distilled water. See, we are adding distilled water when we rinse the inner wall of the conical flask. So does the addition of distilled water in this step 7 in both part B and part C affect the result of the titration? I want you to explain this. So please explain this in your report. Alright guys, so if we look back at the objective of this experiment, so your first objective was to prepare the standard solution of oxalic acid. You have did that successfully, prepared this oxalic acid solution, and then your second objective was to standardize the 0.2 molar sodium hydroxide solution, and your third objective or your last objective was to determine the concentration of hydrochloric acid solution using titration techniques. And then as a conclusion for this experiment, so what can we say about this experiment? So to conclude this, and the molarity of sodium hydroxide solution used in this titration, so in this titration what we get was 0.2003 mole per liter, And lastly, molarity of hydrochloric acid solution using titration is 0.1924 mole per liter. Okay guys, so that's all for this post lab, okay, for this experiment 2. So I'll be seeing you again, okay, inshallah, in the next experiment 3. Still we are going to do titration, but for experiment 3 it is a different kind of titration. It is what we call as back titration. If you want to know what is back titration, so just wait until your experiment 3. Okay, so that's all for now. Bye bye.